Coordinates of the center of curvature for any point P x y on the curve y equal to fx is given by alpha equal to x minus y1, 1 plus y1 square divided by y2, and beta equal to y plus 1 plus y1 square divided by y2. And length of chords of curvature parallel to axis are given by cx equal to 2y1, 1 plus y1 square divided by y2, and cy equal to twice of 1 plus y1 square divided by y2. Now, let's understand these things by some examples. So, question number one, find the coordinates of the center of curvature at any point on the ellipse x square upon a square plus y square upon b square equal to 1. Now, so here x equal to a cos theta and y equal to b sine theta. Now, we find dx upon d theta, that will be equal to minus a sine theta, and dy by d theta will give b cos theta. Now we find y1. So y1 equal to dy upon d theta whole divided by dx upon d theta. We put these values. So b cos theta divided by minus a sine theta. That will be minus b upon a cot theta. Now we find second derivative. Y2 will be equal to minus b upon a. This will become cosec square theta with negative sign. So this sign will become plus. Then d theta by dx. We put the value of d theta by dx from here minus. This is dx upon d theta. So just reverse of it. So b upon a cosec square theta times minus 1 upon a sine theta. So this will become minus b upon a square cosec cube theta. So we have got y1 and y2. Now, let alpha and beta are the coordinates of the center of curvature. Then we know that alpha is given by x minus y1 times 1 plus y1 square divided by y2, and beta equal to y plus 1 plus y1 square divided by y2. So let's find out alpha and beta separately with these values. So I'm deleting as a portion. Okay. So x equal to value of, sorry, not x, alpha equal to value of x plus a cos theta. So a cos theta minus y1. Y1 is this much, minus b upon a cos theta. So minus b upon a cot theta times 1 plus y1 square, that is b square upon a square cot square theta divided by y2. Y2 is minus b upon a square cosec cube theta. Now we simplify it. So this will become a cos theta minus the first term. This will be minus b upon a cot theta divided by this much. Then because of these two minus sign, first term will become plus, and then again will be multiplied by minus sign here inside. So that will become negative, and all terms, these two terms will get multiplied, then divide by this. So let's write it. It will become minus b upon a, and this will become a square upon b. This is sine cube theta in numerator sine cube theta into this. Cot theta is cos theta upon sine theta times. If we take LCM here, so this will become a square and this cot square theta can be written as cos square theta upon sine square theta. So denominator will give sine square theta, and then this will become a square sine square theta plus this will be b square cos square theta. Now we further simplify it and we delete for no portion from here. This is value of y. So this will become b will cancel out, 1a will cancel out, here 1 sine theta will cancel out. So it will become a cos theta minus, this is 1 sine theta, this is sine square theta, so it will become sine cube theta. So this is completely cancelled. So only cos theta will be left. So here 1a will be left because 1a is here, this is a square. So cos theta divided by a times inside a square sine square theta plus b square cos square theta. Now further we multiply this term inside a cos theta minus cos theta into 1a will cancel out. So a into this can be written as 1 minus cos square theta and this minus cos theta upon a times b square cos square theta. Now we further simplify. So this will become a cos theta minus a cos theta plus a cos cube theta minus b square upon a cos cube theta. So we take LCM, these two terms will cancel out. So it will become a square minus b square divided by a times cos cube theta. So this is value of alpha. Now we try to find out value of beta. So for that, let's clear it. So beta is given by y plus 1 plus y1 square divided by y2. And we have y equal to b sine theta and y1 is minus b upon a cot theta and y2 is equal to minus b upon a square cosec cube theta. We can put these values here. So beta equal to b sine theta plus 1 plus y1 square, that is b square upon a square times cot square theta whole divided by y2. Y2 will be minus b upon a square times cosec cube theta. This can be written as b sine theta and this minus sign. This is a square upon b or sine cube theta times, we can write it a square and cos upon sine will give cot. So sine square theta times this will become a square and LCM sine square theta plus b square cos square theta. So a square will cancel out and sine cube theta divided by b, this is sine square theta So let's simplify it further. So we will get b sine theta minus a square upon b, if we don't cancel, sine cube theta, and then next term will be minus b and cos square theta times sine theta, because this is sine cube theta, and this from here, this sine square theta will get cancelled, then we are multiplying. So then here one step I have written wrong. Let's rectify it. So here it should be b equal to b sine theta, and this minus sign, and we write it a square upon b, this sine cube theta, times 1 plus b square upon a square cot square theta. It will be simple. So b sine theta minus, we multiply this term. So a square upon b sine cube theta minus a square upon b times b square upon a square times sine cube theta times cot square theta. Now we simplify it. So it will become b sine theta minus a square upon b sine cube theta minus 1 b will cancel out, a square will cancel out, and this is cos square upon sine square, one sine will cancel out. So we will get b sine theta times cos square theta. Now we convert this cos square theta into 1 minus sine square theta. So b sine theta minus a square upon b sine cube theta minus b sine theta times 1 minus sine square theta. We open the bracket. So we will get theta equals b sine theta minus a square upon b sine cube theta minus b sine theta, and then plus b sine cube theta. These two terms will cancel out, and sine cube theta can be taken outside. So sine cube theta outside, then we will be left with minus a square plus b square divided by 2. So this is value of beta. Hence, we have found the values of alpha and beta, and they represent the coordinates of center of curvature. They also represent the evolute. Now, let's go to next question. We are given Cx and Cy as the chords parallel to x and y axis respectively at any point on the curve y equal to c cos hyperbolic x upon c, then we have to prove that 4c square times cx square plus cy square equal to cy power 4. So for this purpose, we can proceed like v equal to c times cos hyperbolic x upon c. We find y1, and differentiation of hyperbolic function is positive. So here we will get c times sine here d upon dx of cos hyperbolic x is equal to sine hyperbolic x, and d upon dx of sine hyperbolic x gives cos hyperbolic x. So we can use this here. So c times sine hyperbolic x upon c, and derivative of x upon c will be 1 upon c, whereby cc will cancel out. So we have got y1 as sine hyperbolic x upon c. Now we have to get y2. Y2 will be cos hyperbolic x upon c into 1 upon c. Now let's find out cx. We know the definition of cx. Cx is 2y1 times 1 plus y1 square divided by y. Let's put the values. So twice of y1. Y1. So here y1 is this sine hyperbolic x upon c, 1 plus sine hyperbolic square x upon c divided by y2, and y2 is cos hyperbolic x upon c times 1 upon c. And we know that 1 plus sine hyperbolic square x is cos hyperbolic square x. From here, we can write this term as cos hyperbolic square, and from there, 1 cos hyperbolic x will cancel out. So it will become Cx equal to 2c sine hyperbolic x upon c into cos hyperbolic square x upon c divided by cos hyperbolic x upon c. 1 cos hyperbolic x will cancel out, and we will get 2c sine hyperbolic x upon c times cos hyperbolic x upon c. Now let's find out cy. So cy is given by cy equal to twice of 1 plus y1 square divided by y2. So twice of 1 plus y1. Y1 is equal to 1. It will become, we have got y1 as sine hyperbolic x upon c. So we write here sine hyperbolic square x upon c. That will become cos hyperbolic square x upon c, and divided by y2. Y2 is 1 upon c times cos hyperbolic x upon c. So this will become cos square hyperbolic x upon c 2 into cos square hyperbolic x upon c divided by this c will go in numerator cos hyperbolic x upon c. So we will get 2c cos hyperbolic x upon c. So we have got the values of cx and cy. Now we can consider LHS. So LHS is 4c square times cx square plus cy square. So 4c square times cx square. Cx is this much. We can square it. So this will become 4c square sine hyperbolic square x upon c into cos hyperbolic square x upon c plus cy square, this much. This is 4 cos hyperbolic square x upon c. Here c is missing. This is 2c, so this is 4c square. Now, 4c square can be taken out, and also cos hyperbolic square x upon c can be taken out. So this will become 16c square times cos hyperbolic x upon c square, that is, sorry, x upon c. Then inside the bracket, we will be left with sine hyperbolic square x upon c plus 1, and that is cos hyperbolic square x upon c. So we will get 16. Here there was c square also. So into c square. So 16 c power 4 times cos hyperbolic square x upon c multiplied by, this will also become cos hyperbolic square x upon c. So this will become 16 c power 4 cos hyperbolic power 4 x upon c. And if you observe cy, so this is 2c cos hyperbolic x upon c. So this is 2c cos hyperbolic x upon c power 4, which is equal to cy 4. Hence, our purpose is served. Thank you for watching.